So I think a lot of the stuff that we cover in this class is pretty interesting, but nothing is as practical as when we talk about the meteorology unit because we all care about the weather. We care about what it's going to be like today, what we're going to be able to do, what we should wear. So I really hope that you take these skills and use them in your adult life as well. So we are in our atmosphere unit, and as we study this, we're going to talk about not only weather this week, climate next week, and then air pollution after that. So we actually covered the composition of the atmosphere on the very first day of this semester, 47 years ago when we were still in school. But one thing that I want to point out to you is the 1% other gases. So all through this unit, when we talk about carbon dioxide, greenhouse gases, different pollutants, they're all making up less than 1% of our total atmosphere. They're still very important, but they're in very small quantities. How much water vapor is in the air is humidity. And the humidity matters for a lot of different reasons. One is it's going to be the precursor for cloud formation and precipitation in our next lesson. But as a curly hair girl, I care about humidity because it's, hey, is my hair going to be a giant puffball today? Oh, yes. Yes, it is. It also varies as you go through seasons. So North Carolina in the summer's humidity way different than in the winter. So it does affect our weather in various different ways. One thing that humidity impacts is how heat feels to us. So in a place like here where humidity is really high in the summertime, heat index is actually a better scale for us to look at than just what the temperature is going to be for the day. So heat index is looking at both relative humidity and temperature, and it's how does it feel to us. So on certain days, the combination of those two actually becomes pretty dangerous. They'll say things like, make sure your pets aren't outside, or they'll say, if you're going to exercise, make sure you go in the morning or at night, not during the middle of the day. So it does really impact us, especially here. The last thing in the atmosphere that we need to talk about is condensation nuclei, which is just a fancy name for little tiny solid particles in the atmosphere. So that can be things like dust, salt. Goodness knows we've got tons of pollen particles in the air right now. So all of those things are going to be important. Some are going to be pollutants. Some are going to be those condensation nuclei, which we'll talk about in the next lesson. Now, in a traditional semester, we would go through all the different layers of the atmosphere. But for now, let's just cover the two that really impact us the most. So the first one is the troposphere. That's the layer that we live in. So it's right here at the surface. And it's really important because that's where all weather occurs. So weather is not happening all through Earth's atmosphere. It's just our layer. And it's also where air pollution collects. So when we talk about air pollution, it's not fading off into space. Every bit that we pollute the air is staying here, and it's accumulating year after year after year. The other layer is the stratosphere, and this one's important because that's where the ozone layer is. So as the sun radiates towards us, it has UV, it has heat, it has light. But what's important is the stratosphere's ozone layer actually absorbs about half of all of that radiation before it even hits the surface, which is good because if all of the sun's heat or all of the sun's radiation hit us, we would basically be fried bacon and we wouldn't really be a planet. So we should wake up every morning and say, thank you, stratosphere, for keeping us alive. Always important. When we talk about the weather, the two major things that we talk about is what's the temperature for the day and what are the sky conditions for the day. So for Earth's temperature, there's just a couple of basic things that really impact what the temperature is going to be like. Most of them are fairly straightforward and common sense. So the first one is geographic position. So if I said, hey, What place is having warmer temperatures today? Alaska or Mexico? Without having to look up the forecast, most of you would say Mexico because it's closer to the equator and we know that it's typically warmer than Alaska, which is closer to the poles. So that's all geographic position is saying there. Where you are on Earth is going to affect what your temperatures are. The next one is altitude or elevation. So most of us know as you go up in elevation, the temperatures get cooler. And you can see that a lot of times when you look at photos of mountains, because a lot of times the tops of the mountains will be covered in snow because they're below freezing, even if the bottom of the mountain is well above freezing. The last one may not be as familiar to you, so it's surface material. Are you a place near a body of water or far away from a body of water? Because what happens is water actually regulates or stabilizes the temperatures near it. And the major reason for that is that water has a high specific heat. So specific heat just means that it takes a lot of energy to change water's temperature. So it's slow to get the memo when there's a season change. So in the springtime, when we start having pretty warm days, the water's like, oh, wait, it's not winter anymore? So you can see in the picture there that the beach forecast for that day was 73 up on the land, but the water temperature was still a very chilly 66 degrees because it hasn't quite warmed up yet. It's also slow to cool down in the fall. So hurricanes are fueled by warm ocean water. So it's kind of weird to think about that sometimes we get hurricanes in September and October when we think about it being cold. But the thing is, the ocean water is still relatively warm, so it still can produce hurricanes. So I said that the two major things that people describe when they're talking about weather is what is the temperature and what is the sky conditions. The sky conditions are indicated by what kind of pressure there is. So air pressure is just the pressure pushing down on us from all the different layers of the atmosphere. On particularly high pressure days, it's typically fair weather. Now, my mom, not a meteorologist, but she came up with this saying a long time ago. She said happy highs and lousy lows. So for high pressure systems, she calls those happy weather because it's fair weather, it's clear outside. Low pressure systems, she called lousy lows because they tend to be cloudy, rainy, stormy days. In fact, all the storms that we talk about in our next lesson are all low pressure events. So happy highs and lousy lows. So I wanted to show you this weather map here because this is real stuff that we're talking about. So you can look there and see the places that have the high pressure systems have sunshines beside them, and the places that have low pressure systems have some form of precipitation. Some have rain, some have snow, but all of the low pressure systems have that precipitation. So happy highs, lousy lows. Another thing that's impacted by air pressure is wind. So wind finds an imbalance in pressure. So there's there's a high pressure system and a low pressure system, and the wind will move from one to another. Or there's warm air and there's cold air, and so it'll move because of that. In the United States, most of our wind, and so most of our weather systems that are moved by the wind, happen from west to east. So that storm system that's over North Carolina in the weather map there is headed off the coast. So it's moving from west to east. So the last big thing that we're going to talk about today are weather fronts. You see these all the time on weather maps if you ever look at those. So the first one is a cold front. Now, a cold front comes pushing in and shoves the warm air up. because remember, warm air rises. So the cold air comes in and shoves the warm air out of the way. And what's really important for you to know is what the symbol is for these, because we're going to be looking at some weather maps today. So it's blue, which is good. That's what we associate with cold weather. And it's triangles, which a student said a long time ago that it reminded them of icicles. I was like, ooh, that's a good way to remember that. So blue line with blue triangles is your cold front. And notice that the way that the triangles are pointing is the way that the air is moving. So the colder temperatures in this picture are on the left side and they're moving to the right. And we indicate that by having the triangles on the right side of that front. Warm fronts, on the other hand, come in and the warm air replaces the cold. So on a weather map, we're going to have red, which is good. That's what we think of when we hear warm. And it's going to be semicircles for that. Same thing there. Where the semicircles are pointed is where that front is moving. Next up are stationary fronts. Now, when something is stationary, it's sitting still. That's exactly what a stationary front is doing. It's basically like a tug of war where two sides are equally matched. So there's the cold air on one side, the warm air on the other. Neither of them are strong enough to push the other one out of the way. So they just kind of stay there and bump heads and dump a bunch of rain somewhere. So the good news is, because it's a combination of cold air and warm air, that's exactly what its symbol looks like. So it's going to be red and blue. And the semicircles and the triangles are going to be on opposite sides of each other because they're butting heads with each other. The last one, to be honest, I have only seen on a weather map like 3 times. So it is not a terribly common weather front, at least here. Maybe it is other places, but it's called an occluded front. And it's kind of funky. It actually involves 3 air masses. So if you look at the picture on the left, there's really cold air, there's cool air, and there's warm air. And that warm air gets wedged upwards because the cool air and the cold air are ganging up on it. So an occluded front is going to be purple, like red plus blue together. And this time, the alternating semicircles and triangles are on the same side as each other. So that's how you can tell the difference between it and a stationary front, even if it's in black and white. All right, that is it for today. Make sure that you analyze those weather maps, folks.